Hello everyone, this is Olsen, the TA for MEC 316 lab, and this video is about the demonstration of the experiment number 11, which is stress distribution determination of a bending beam. So this is the specimen which will be actually given to you, and the strain gauge sensors are already attached to it. So the first thing you need to do is please read out this handout manual by Professor Amin Fakhri and Professor Jangun Han, and after reading that manual thoroughly, including the theory and procedure both, then just follow the procedure which is mentioned. So let's begin with that. The first thing you need to do is measure the width and thickness of the steel specimen which is given to you. So you can use the vernier caliper which will be given to you, and this digital caliper shows 3 mm as thickness and about 25 mm width. So now, since you have conducted another experiment as well related to the strain measurement on the same apparatus, here you can see that the specimen holders are already removed from that apparatus. So please make sure that the crossheads are actually installed on the testing machine. So let's install those. This is like a 210 millimeter width crosshead, and this is like a bending stress indenter. Okay, so fix the lower stop screw at 270 millimeter. So now I would like to make you see a closer look. 250 millimeters. Just take that down up to 250 millimeters. And then please turn on the apparatus main switch from here, and from this remote you can just move that downwards, and you need to move it down until 280 millimeter. So you can just press it down one time and it will start moving down, and you can just see the descending rate here as well. However, if you press it 2 times, it will descend actually faster. So just keep an eye until it just gets closer. There are faster ways as well to move it down, but I think it's still safer for you to just move it with that quick speed one. And then as it gets closer, you can just slow it down by pressing the downside button one time, so it will just turn to the minimum speed. Since now it still has like a little more distance, I'm still descending it faster. And so we have to take it down by 280. Well, the upper limit is just kept to keep a little gap from here, but please keep in mind about that lower screw, that it should not be like below 250 mm. The reason is because this steel has, the specimen has its own bending limit, and after that it's like it will not be in its elastic bending phase. So it's like a safety check for you, and after that we need to place the specimen exactly in the middle of this holder support. So I can show you, this specimen contains marked lines as well, and the net distance between those lines is actually about 210 millimeter, which is the exact size of that support. And now after that we will now begin with the experiment. So the next step is we need to connect those strain gauges with the strain indicator that you guys have already done in the experiment number 3 as well, which is related to the strain measurement. So let me just turn the strain gauges, strain indicators. So there are about 8 total strain indicators attached with this specimen. So you can connect 4 of them each to the strain indicators one by one. So you can just remember it with the order as you are connecting. For example, I'm connecting it from the first one, and it's actually shown on page number 85 how you are going to connect. So that says that you have to connect that red wire with the P plus, and the others will be the resistance wires that are going to connect with S negative and D. So you can clearly see that P plus, S minus, and D, and we have to connect all of those in that order. Okay, so I connected the upper side, top side strain indicators on one of the strain indicator equipment, and the lower ones all on the other strain indicator equipment. So now I'm going to turn the power on for both. So you can clearly check if they are active or not, and moreover if they are balanced or not, and how is the situation. However, after checking this thing, the next step is to come to the computer and go to the Horizon software. It's right here. The purpose of this software is, though we can actually just pull down this indenter type thing for applying the like some source of force for as a bending force, but this is like an unconstrained force. But in case of software, we are actually going to record that, and we will set the speed as well. So here I'm going to tell you one of the important thing, which is though mentioned in the manual as well, but probably is better for you to see here if you find anything which is not clear from reading the manual. Okay, so now the first thing, so this is, by the way, the step number 7 of the procedure. Now what you need to check is from the test and recall tab here, we need to go here for add a new testing tab, because we don't need to go to the demonstration tab, which now it is actually showing you a demonstration mode. So just exit the demonstration mode. For now, just open a testing mode, and here keep the machine source same, and in the method we have to select the compression test for steel specimen, but the compression test is actually like the application of the test is similar, so go on this tab, and please make sure that this demonstration mode is not checked. Okay, now in the testing mode, make sure that it's not like the batch mode or the unknown number or fixed number. Do it single mode. and then click OK. So you'll see a window like that in which you can probably see that the force and the position of our indenter now seems much active and movable. So here is the way to turn it to 0 even if it's not showing as 0, like that. It just turned into 0. Okay, now we need to go to the testing window. This is the testing window. So here we need to choose a name for our sample. So I'm typing it as experiment number 11 demonstration. You can type any name what you want, and then speed of the test, it's better to keep minimum. The manual suggests to keep 5 millimeter per minute, which is pretty okay, I think. So just follow that. So preload. For the preload section, let's keep it 0 and endpoint. So now, if you remember, since we have fixed it by 250, right? So this is like our endpoint. So we can keep our endpoint by 250, but even if we keep it like 255, so this will automatically actually is going to block the circuit after that. So it means that our mechanical screw is going to provide us the support in case of failure, but actually the circuit will get, like, it will break here. Now, you remember the first point said that you have to measure the width and thickness of your specimen. So here you have to enter it. The width of the specimen, what I measured was 25.36 mm, I guess. You just enter your value, and the thickness was 3.06, what I measured. So area you don't need to enter because it will calculate on its own. So this one, all of the red indicated ones are actually the one you need to enter. The specimen height. Now the specimen height is so for setting the specimen height, now let me actually, so there are two ways. One is actually to measure the difference between the specimen and the indicator, which is like the gap between that, or the other way is I just manually make it touch so that I can enter the value 0. So I'm just going to slowly move it manually down to touch it and then note down the value here. So It's like almost in contact now. So we have to enter it in inches, and here you can see that the inches are also mentioned. So beneath 9 is 10 and it's 11 inches almost. So mention 11 here, and here we go. Just press this green button. By the way, just turn this to 0 once again, and here we go. So you see that the reading started changing, and I'd like to show you that it is suddenly it's like slowly moving down gradually. It has a limit. And at the same time, you can see how the graph is getting plotted. The graphs are between stress versus position and the force versus position. By the way, you can even see the strain indicators as well. How much strain are they indicating? And how much is it compressed? So here we can see that now, since the elastic limit is breaking, so I'm actually stopping it here. And you'll see that it suddenly released and just turned back to its previous position. And this is the graph that we have obtained. Please make sure that it just doesn't go over the 0.28 or 280 millimeters. Sorry, 0.28 inches side, in order to avoid that deformation thing. So here you can see it's almost linear graph, except just like a little shake or jerk here. That's all you're supposed to do. Please make sure to attempt the experiment 3 times for this specimen to get the accurate results. The requirements are to plot the graphs, which the software is actually going to plot for you. I hope you'll enjoy this experiment. So thank you everyone. See you.